Hello, everyone. This is Francisco. First, and our apologies for the delay. For some reason, the moderator of this session was not able to connect. I want to welcome everyone to the 2020 APAC Groundbreakers Virtual Tour by APAC UC. This year, our event will be the biggest one ever done, with 174 sessions, including normal sessions, workshops, and hands-on labs, from 123 different speakers over 11 days. Also, it will cover sessions on 4 different languages, and please remember to register to as many sessions as you can. And all sessions will be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, what's your superpower? Mine is Machine Learning with Oracle Autonomous Database by Jim Siprunsky. Hopefully I pronounced that correctly, Jim.
Perfectly.
And please feel free to write questions and any up at the Zoom webinar, and the speaker will be answering them at the end of the session. If any issues during the presentation or you have any questions to the organization, you can contact me, the moderator, at any time by using the chat in the Zoom webinar. Basically, questions to the speaker using the Q&A tab, questions to your organization and the moderator by issues of anything, please use the chat. Now, without any more delays, I would like to leave you with this amazing session by Jim Siprunsky. Okay, Jim, I will stop sharing and you can take control.
Thank you, Francisco. Well, I see it's 1 in the afternoon by you guys, and let me just close off my speaker view there. Can everyone see that okay? I hope.
Not yet. I cannot
Not
see
yet.
your,
Okay, let's get back in here and make this work the right way. Oh, I see. Okay, never mind. My bad. Helps if you click on the right button. Small technical issues. There we go.
Perfectly. Well, no. All right.
Perfect. Okay. Sounds good. Well, let's get rolling. So thanks for that really nice introduction. Francisco, I really appreciate it. A little technical difficulty today, nothing new in our business, right? My topic today is actually pretty far ranging, so I'm going to dive right in. I'm not going to spend a lot of time talking about myself. I've been doing IT for 4 decades now. And really in the last 20 years, I've been more of an Oracle DBA, but in the most recent iteration of my career, if you will, I've really started taking a look at machine learning and analytics because that's where we're headed. By the way, this is my personal contact information. You can follow me on Twitter. You can contact me on LinkedIn. I'm heading towards, I hope soon, 10,000 connections on LinkedIn. Takes time, but would love to have you as a connection and love to have you as someone following me and vice versa. One of the things that was really interesting is we have a little magazine here, a satirical magazine in the United States called The Onion. And it dates back many, many years, very sarcastic, very joking, right? Always kind of a tongue-in-cheek one. And I found this article about a year and a half ago, and I thought it was really great that, you know, this is what, when you get into a machine learning or analytics mode, you start thinking about things like this, that, hey, 3 guys show up to work at the same company, basically dressed with exactly the same shirt color. That's the kind of things that we're starting to see in our industry. And one of the more interesting things about where we are today in our industry, right, is the role of the DBA is changing dramatically. And again, as a DBA and someone who trained over 2,000 DBAs as an Oracle University instructor, I've seen this too. I saw this stat from CIO magazine that 90% of app developers say that it's the DBA, well, the database, but let's be honest, the DBA, a lot of times causing them grief because the applications aren't getting rolled out fast enough. And why is that? Well, to be honest, DBAs are gosh darn busy. First of all, 4 out of 10, 2 out of 5 DBAs these days are handling 50 or more databases. And we're still doing about 75%, almost 3/4 of our budget, 72% roughly. These statistics are about a year and a half old, is still spent on keeping the lights on. Here's the interesting thing. If you're a DBA, or maybe you've seen a little bit of the always free layer or whatever it is, you're thinking about becoming a DBA, realize that DBAs are probably the best folks to help transition your organization into a digitally driven or a data-driven orientation, because that's where we're heading. The world of specialization is gone. It's leaving very quickly. And one of the things that I always remember is hearing about this guy, General McAuliffe. I'm going to speak about him real quickly because my father-in-law, has passed on many, many years ago, almost 50 years ago, 45 years ago, was at Bastogne in Europe. And that was a battle during the last parts of World War II. The Americans were completely surrounded. The Germans said, you know, please don't slaughter yourselves. We'll give you a surrender. And this guy responded with the word nuts. You may have heard of that story. It's a legend in the 101st Airborne of the United States. He said nuts because he didn't swear. He didn't like using foul language. He also did tell his troops, and this is what's appropriate that I really want you to get from this. We have the enemy exactly where we want them. We're completely surrounded. And this might be how it feels as a DBA these days. We're completely surrounded by all kinds of changes. We can attack in any direction. Why? Data is the new oil. Well, if it's the new oil, you hear that all the time, right? And it's miners or it's plumbers, it's refiners or data scientists, then we DBAs, and I lump applications DBs and even application developers in there with them, because we're the roughhousing guys. We're the guys that actually get the pipes and drive them deep into the ground, because we know really where the oil is in many cases. The data scientists are going to make it into gasoline and kerosene and everything else, whatever they need, but we're the ones that help them plumb for that oil. And what's really great about where you are today, if you've got an autonomous database, or you've at least played with it a little bit, I'm going to be showing you some examples from ATP and ADW. If you've played with this some, you realize that it's a force multiplier, right? I have an ATP instance that, I am not kidding, I have not looked at to see if it's healthy in almost 10 months. I haven't had a look at it. In fact, it just got upgraded to 19C, and I didn't have to do a dang thing. Oracle upgraded it for me. And by the way, upgraded my Application Express version automatically to 19.2. One of the things I love about especially the autonomous database setup that we have right now, whichever one you pick, you've got an Application Express instance. You don't need to set up an ORDS instance. You don't need to do anything special. Bang, it's there. You can get to it right away. And that means you can build applications much more effectively. Again, I don't have it in this presentation, but I'll have in tomorrow night's presentation an example of how I was able to use Apex to essentially leverage data inside spreadsheets, Excel spreadsheets that a particular client, if you will, of mine leveraged to gather data and actually build part of an application directly out of it. If you don't have an Excel spreadsheet, you've got APIs, right? More on that tomorrow when we talk about Apex a little bit more, kind of an Apex for the DBA, if you will. But REST APIs, especially Oracle's REST APIs, means I don't have to learn how to write SQL anymore to do inserts, updates, and deletes. Selects maybe a little bit, but again, if I'm just drawing data out, a REST API is magnificent, right? And I'll talk more about that tomorrow night when we talk about web source modules. But finally, here's where we're going, right? Here's what I want you to really get, that if you haven't figured this out yet, data mining is built into Oracle extremely deeply, right? Oracle has R built into the Oracle database at a very low level. And you've got everything you need to do to build data models right now. It's built into the database. Does that mean you don't have to know a little bit about what you're doing? I never said that. You do have to know a little bit about it. And here's one way you can get to OML, Oracle Machine Learning, and analytics in less than 10 minutes. I'm going to take you there in less than 10, I swear. So here's some of the things to know about, right? By the way, this link should work, and I'm going to send out the slides a little bit later. But one of the things to understand is that built into Oracle are over 24 different machine learning algorithms, some supervised, some unsupervised. I'm going to show you some examples from that a little bit later here. But you can do, this is only the top of this one-page doc that has all the different types of things you can do: clustering, regression, time series, classification, and anomaly detection through these algorithms. You don't have to write your own. They're already here. How do I get to them? Here's one of the things that's beautiful. If you build an ADB instance, whether it's ATP or ADW, you can create an OML user. Guess what it is? It's a schema. Yeah, it's a schema inside your database. That's actually what I did here. I created a user called AIMLNOOB, like newbie, right? And I actually did this right through the OCI console and said, send this guy an email and tell him he's got to reset his password as soon as it comes through. I get an email on my email address, right? I go ahead and log in at using that link. And again, this screen may look a little bit different from what you'd see today, right? Oracle's always switching up the OCI interface, but I set my new password and I'm off and running. And I've got this schema now called AIMLNOOB. I'm immediately in a position to start using a Zeppelin notebook. I can create my own projects, my own workspaces, and then within those workspaces, my own notebooks. And we're going to look at several different examples of this in the next few minutes. In this case, I created my own workspace. Notice I'm logged in as AIML noob. That's me. And now I'm going to create a brand new project. It's called stock trends, because I'm going to be analyzing some data from a TPCE schema. Yeah, this particular schema actually lives inside an ATP instance. Yeah, I know ATP is not perfect necessarily for a data warehouse, right? But that's okay, because every online transaction processing system I've ever worked on has some element of reporting, right? Somebody wants to get data out of it relatively quickly. Well, why not be able to apply some analytics at it? Anyway, I create this new project. I create my first notebook. It's called Basic Trends. What am I going to be analyzing? I'm going to be looking at some transactions and see if I see some patterns. And I'm going to dive into them real quickly by first creating, I should say, granting privileges to that particular user. Notice I did this inside SQL Developer. By the way, I could also do it inside machine learning, inside the OML login, if I had the right privileges. It's just easier to do inside SQL Developer, or I could have done this obviously from a SQL Plus window or even SQL CI. And then I built a little query for 3 months worth of data from the year 2005. The TPCE standard schema, by the way, has data from 1998 to 2006. That's just the way it's built. That's why I picked that date range. But notice I'm joining together about 9 different tables in a little select statement, right? And now I'm going to go ahead and run this. I love this. Inside the notebook, we have the concept of paragraphs, right? Well, what is this? In this case, it's just a SQL statement. And I'm going to run it and get some data out. And what am I going to do with these data? Well, first, I'm going to display them. Here they are, right? And one column I'd like you to focus on right here is the second to the right one that says T_TT_ID. That stands for transaction type, for stock transaction type. And there's basically 5 different types in the TPCE model, right? This is all bogus data. It doesn't really mean anything, right? It just to use as an example, but you can see here's the data. Well, that doesn't tell me much. So let's see if we can get some realizations from it. Is there anything we can get from it? Yes, by simply clicking up here on this little bar, I can go ahead and start making some visualizations of data. Okay, it's a pie chart, not my favorite chart. What am I graphing here? The different transaction types and a count of the number of equities that were sold. Remember I told you it was basically a stock trading system? So what am I trying to do here? Just, hey, dear Oracle, OML, please share with me what types of transactions and what's the volume of transactions based on just rough counts of how many equities were sold or bought or sold in a different way, right? Here's what I love about OML and Zeppelin. Let's say that I know there's another layer, in this case, the country. of where the stock trade happened. All I had to do was drag ADCTRY into this box, and immediately, bang, I now have a pie chart that shows not just a count of how many equities were sold within each individual type, in this case, market sell, right? Sell the stock at market, if you will, sell the equity at market, but also within which country. And if I scrolled around through here, you'd actually be able to see that each one of these actually, I can hover over it and get the data. Okay, I don't like pie charts much. Neither do you, maybe. Would a stacked bar graph make more sense? Yeah, with one mouse click up here, I switch from a pie chart to a stacked bar graph. And I could even pick different values, right? I said, here, sum the total quantity. I could come in here and say, you know what? Drag in average bid price, drag in trade price, but give me the maximum of that and get rid of quantity sum, right? Or I should say total quantity, the sum of the quantities, right? I could do that right here and get some basic visualizations. I know what you're thinking. Jim, this isn't machine learning. No, it's visualization. Machine learning, though, usually has one of its results, some way to visualize the data a little bit better. Here's the cool thing about Oracle. Remember I told you all the algorithms are built into the database? Let me show you this. There are built into OML, I don't think this has changed since the last time I checked about 2 or 3 weeks ago, about 8 different examples using standard schemas that are available in every single ADB. The SH schema is always retained in every single ADB that we have for example processing, right? And forget my first notebook. Obviously, we don't need that. We've already built our own. But look at these other types of notebooks that we could build. Guess what they're all focusing on? A different way of using machine learning and analytics. And here's a simple example. What I love about the way Oracle built this and these examples is, if you're trying to figure out what you're trying to do, you got a little graph here that kind of helps you, right? A little graphic. And here it's, oh, I'm going to take some sales data. This is from a totally different database, friends. This is from my TPCDS database, my ADW database that has a TPCDS schema that has sales within different markets, right? And what I want to do is forecast out sales using existing data. And by the way, here's the secret: DBMS data mining. That's really what's happening underneath the covers for everything we're doing with Oracle Analytics. Really, for machine learning, that's what we're using, the DBMS data mining package. And, you know, to be honest, till about 1.5 years ago, I didn't even really know much about this package. I was a core DBA, right? I wasn't focusing on this as much. I started diving into this and I'm like, my gosh, I didn't even know this was here. I didn't need to because I was just a core DBA. But as a data science enabler or a data science engineer, I needed to know it. What I'm actually showing you is an example of building what's called an exponential smoothing algorithm, ESM, and applying it to some data. In this case, this is examples all based on the SH schema. I'm sharing with you what's built into OML so that you can understand how this all works. And what I'm doing is basically forecasting on the good old sh.sales.amount sold column. And I can look in depth to see which type of algorithm is being applied, and even some stuff that, unless I'm a data scientist, I don't have a clue as to what all these things mean. I do know some of this, right? I understand what a confidence level is. I understand what an interval is, right? Basically how I'm going to do my predictions, and some other factors. The beautiful thing is, folks, this is all beautifully documented inside the Oracle manuals on DBMS data model, right? So even if you're not a data scientist, you can even get in here and try to understand a little bit more about this, right? The other beautiful thing is that Oracle hides nothing from you when you're using DBMS data model, right? Because what you're really doing inside here is you can see all the attributes and all of the diagnostics quality, diagnostics of the model's quality, I should say. I got a really great example of that coming up in a few more screens here. But this is the beautiful thing is, again, I don't know what all these things mean. I know what alpha means. I know what beta means. I know what some of these mean. As soon as I saw this, I went, this is like back in the day when I was trying to understand which mutual funds I should buy before I retire, right? And alpha means something about how closely a measurement hews to essentially the other funds in its category, right? So I'm like, oh, I know what some of these things are. I don't have to be a data scientist to understand all these things. But again, beautifully documented, and the model tells you exactly how well, how high of a quality it actually is producing. And here's where we get into the value of visualization. See those light brown bars, really parts of the graph over on the right-hand side? That shows you the upper and lower boundaries of how accurate the projection of sales from 2002 January through December actually are, especially with COVID, right? We've seen these graphs of if we don't flatten the curve, and here in the United States, let me tell you, some of our states have not done a very good job. I'm in Illinois, we've done pretty well. Just to the north of me, Wisconsin, not so good. Lots of hot spots up in Wisconsin, right? Because people aren't following best practices for COVID. And remember, if you saw the graphs back when we were talking in March and April, if we don't flatten the curve between this many and this many people could get infected. That's exactly what we're sharing here. It's the same kind of concept. It's a time series forecast, right? So then what I did is I actually did a little bit more research into some of these, and I played a little bit with some other types of machine learning modeling. One that's an example is attribute importance, right? And again, I love these little graphics that basically say out of a jumble of all these things, we're going to identify which particular factors, right, have the biggest impact on a particular measurement, right? This is a good example of, say, trying to figure out of several different types of attributes, whether it's the customer's gender or their income level or where they live or how many children they have even, or what's their education level. What seems to be the biggest impact on their behavior? In this case, what they're actually sharing with you is, here's a way of looking to figure out if they're joining our frequent buyers club, right? And these type of analyses are extremely important to many businesses and many other organizations as well. I'll share with one with you a little bit later in a few more minutes. What I then did is I used these same principles, and I took these same principles and applied them to my TPCDS data for a very limited amount of data. I just wanted to see what actually would come out. And wow, I got exactly similar results. I got that dark brown and light blue line, and that's basically telling me, right, a lower and upper bound of how accurate that light brown line all the way on the right actually is, right? Another thing I love about visualization, by the way, you may notice it, is right here. The 2003 January, right before 2003 in January in my test data, what the heck's going on here? It could be missing data. It could be COVID, right? If this was a restaurant, if it was a hotel, that's probably not that unlikely, depending on where you were in the world in 2019 and 2020. Probably not the graph for Amazon sales at this point in time, right? It's probably like right up through the top, but you get the idea. I can take past data and with some degree of accuracy forecast forward within boundaries what I believe sales are going to be. Okay, so that took a little more than 10 minutes, but here's the thing. OML is really designed for data scientists, right? I threw a lot of stuff at you there, but you still saw it wasn't that hard to pull this together. You're basically now a junior data scientist. What if you're really junior? What if you really don't know much about the data that you're perusing? Let me share with you something else, Oracle Analytics Cloud. Now, Oracle Analytics Cloud, or OAC, is not free. You have to pay a little bit extra for it, but I want to share with you why you might be interested in it, right? OML comes included with autonomous transaction processing or ADW databases, right? But this you have to pay a little bit more for, but I want to share with you why it's so cool and where it fits into the big picture, right? If our jobs as DBAs, apps DBA, core DBA, even application developers, right, are going to be focused more and more on being digitally driven, there's probably an autonomous data warehouse in your future, or an ATP instance, or totally different topic for next year when I'm working on autonomous JSON database. You got JSON documents, we can give you an autonomous database that focuses primarily on those types of documents, right? Focused on that. Some really cool stuff you can do with AJD, by the way. But I just want to share with you, right? Let's take a look on that left-hand side for a bit, right? The data could be literally coming from anywhere, from our enterprise applications, from any other external source, or some comma-separated value data sets, right? It could be a flat file. It could be a file in a Hadoop cluster. And by the way, this concept right here is what Oracle terms these days a converged database. One database is all you need. And all of this stuff is built in. Now, Analytics Cloud is a bit of a bolt-on, but I'll share with you why I find it so intriguing. I've been working with a United States Congressional Campaign, an election campaign. In fact, I'm volunteering as an election judge for the first time in my life. Actually, on my birthday, I will turn 63 years old on our presidential election, our national election on November 3rd. I'm really excited about it. Not the birthday, the election. And I've actually been working with the campaign for over 2 years now, and we've done some interesting analyses on voting, right? In the United States, when you vote in a primary election, we know who you declared for as a party, not who you voted for. And we got quite a bit of detail. It's public records. Actually, this is not that uncommon in many countries. So I was able to play around a little bit with some data that the campaign allowed me to access. And I'm going to share with you some of the things I was able to do with it, because it's quite interesting. And the reason I bring up elections is all of us understand it, right? Probably since 6th year of being alive, we voted for things, right? The data that's available has all kinds of marvelous levels of detail, including ethnicity, age, gender, even income level, and which party the person declared for in the primary election. And so one of the things I was very interested in is, hey, are there any people here who could be shifted from, if they were Democrat to Republican, or from Republican to Democrat? Have I seen a pattern of that voting in the past several elections? And I was able to gather some of that data and play with it. But first I wanted to get a handle on what a typical voter population looked like inside our county, right? Or actually, I should say inside our congressional district, which is about 475,000 people, but about 280,000 registered voters, right? So 500,000 people, right? Not a small group. I was able to pull some data together, but it was like, well, I don't know. This may not be quite as complete as I'd like it to be. Is there anything else I can do with it? So I pulled it into Oracle Analytics Cloud. I'm going to go through these screens relatively quickly because I want to share with you some really cool stuff you can do with OAC that you can't really do with OML, all right? So here's my data set, right? It came out of a database, an ATP instance called Recloned, because it was. I cloned it from another ATP instance into a more powerful example database. And I pulled data from the Vivo schema, and I created a view based on that select statement I showed you called voter cluster demographics. And then I pulled that data directly into Oracle Analytics, and it says, hey, Jimbo, what of these columns are you interested in? And notice that I pulled several different columns from that view, including some of the ones that I sort of decoded with those decode statements, right? And here's what I want to share with you that's really cool. It says, well, I've seen these data over here, and here's a dump of data within these groups, different groupings of ethnicity and income level and so forth. But would you like to take a little bit more of a deeper look at your data and actually get some help? And that's where I'm going to shift over to a live demonstration actually of what I'm doing here. Here is that same data that I just pulled up from my voter cluster demographics view. here's what I love about OAC. Check this out. I've got a postal code here under this column, vCitus zip. And OAC comes back and says, I've got 13 different recommendations for you, including, would you like me to enrich the zip code with latitude and longitude? And with one mouse click, I've just added, where'd you run off to? There he is. I just added the city center of these zip codes on a map. I now have everything I need to map this if I wanted to, right? On any kind of map. I could take these data and drop them, with a little bit more manipulation into either Oracle spatial and graph tools, or even onto a Google map if I wanted to do that, right? So the idea behind OAC is, yeah, it's a little extra charge. It's not that bad, right? It runs on its own little virtual server. But the beautiful thing about it is it's enabling me as a citizen data scientist, if you will, to do some things that otherwise I would have to scrape this data a couple different ways from Tuesday to get to this point of getting the latitude and longitude. And notice there's other things. It didn't even let me say, hey, I can tell you how many feet or meters above sea level this particular zip code is. That's not too bad. That gives me 3D representation, right? Not too shabby. Back to my presentation. So I shared this with you, and I just wanted to share here, basically the second part is where I actually was doing some of that analysis, but this is real time. I now wanted to share with you the actual graph that I was able to pull from this, right? Because really what I like to do is get a better viewpoint into what's going on inside that data source. I can simply say, dear Oracle, now that I've extracted the data and possibly enriched it the way I shared with you, I would like to pick any one of these different graphs in several different formats, including radar graphs, line graphs, area graphs, categories, even different types of mapping and tree maps, and drag it directly into a particular graph. And in this case, at this point, Oracle's Analytic Cloud says, you're going to need to save this as a project, Jim. And I said, no problem. I'll save it as a project called Voter Demographic Analysis. You ready for this? If you were a data scientist right now, you'd be drooling. Let me explain what this graph actually shares. Number one, the affiliation in terms of which party you were most likely to vote for is represented by a color here. Blue, Democratic, one of our parties, and green, GOP, or Republican, as it's called. Also, note, I'm not just graphing that, I'm also graphing the number of registered voters that have affiliated themselves that way, but I'm also, based on the symbol chosen, listing out what their ethnicity is, whether it's white, black, Hispanic, Asian, and so forth. And I can see right from here, very interesting. It seems that young white people in our district are much more likely to vote Democratic, until they reach about the age of 60. And not too many folks voting Republican until they get a little older, and then, well, as they die, it drops off, is about what it comes down to. I actually found that the oldest voter in our congressional district is 104 years old, and yes, she's a Republican. What can I tell you? The point I'm trying to make here is this is gold. This is the kind of stuff that data scientists used to dream about being able to pull together. I did it with a few mouse clicks and a little bit of SQL. That's pretty impressive. Finally, if you want to get off to a quick start, by the way, I had been working for Viscosity until about May of this year. But while I was there, I just wanted to mention, we got some really nice little, I think they're still out there. You can go to these different links and actually take a look at a short presentation on how to use either OAC or OML. So that's there for if you want to take a look at it, but I wanted to just share a little bit more with you about Application Express, right? I've really gotten to Apex in the last year or so. That's what my presentation is going to be on tomorrow. Here's the beautiful thing. Maybe you can't afford OAC. Maybe you don't want to take the time to invest in learning yet another tool. Maybe OML doesn't give you the graphs that you really would like to have, and you'd like to do some other things. Maybe you already have an Apex instance. Guess what? Everything you do with OML or OAC ends up being an object in your autonomous database. And remember, since Apex is already included in the ADB layer, you can start to build applications right away that use machine learning techniques inside your Apex applications. Let me share one with you real quickly. What I did, because let me just grab a sip of my decaf coffee because it is almost 10 o'clock here in the United States. To wet my throat a bit, there we go. I actually did an analysis of whether or not any voters would be flippable. Actually, the proper term is what's the elasticity of a voter? How likely are they maybe to vote against their party affiliation in the past? And the graph I'm sharing with you here is built into an Apex application. I'll share this again tomorrow, by the way. This is not anything to do really with the elasticity or the flippability of the voters. I'm actually graphing the accuracy of the unsupervised decision tree model spread across, in this case, 30 quintiles. Quantiles, excuse me, not quintiles. That's something else. And the point I'm trying to make here is I'm actually, if this was live, I could click on run model and I'd be building a brand new version of the data model. I'd essentially be redoing the test of the decision tree model, because decision tree is a teach and then learn model. Teach the model with at least 60% of your data, use the other 40% to test that model. And when I'm actually able to see here, again, this is just a simple classic report, how accurate is the model? And one other little report that I'm adding into my app in the next few days is really these statistics all translate to how many false positives and how many false negatives do I have? That's really what these stats all come down to. How do I get that information? It's already inside my machine learning models. And just a few other things. Hey, remember we talked about zip code and how I could easily get latitude and longitude? Part of one of the other projects I did was there's some really neat Apex plugins for Google Maps that you can actually leverage. And this was an interesting one. I basically identified the red dots on this map are essentially locations of where particular voters that might be flippable live. Why? We were doing this analysis pre-COVID, okay? Normally what we'd be doing is knocking on their door. No, today we would be texting or phoning them and trying to see if they voted yet, right? Depending on where you are in the campaign. And really, it's not that different from trying to find out where your customers are. Are they clustered around one particular point? What else would this map tell me? How many salespeople do I need to cover this territory, right? If this is actually quite a small area. This is only about 2 square miles. I should say 4 square miles. It's about 2 miles by 2 miles on this actual Google map. How many salespeople do I need to cover that? I've got a pretty good idea of what that might be. Here's some useful links and documentation, by the way. There's that cheat sheet that I had in OML, by the way, if you saw it earlier in this presentation when we got started. Finally, I wrote a pretty exhaustive article for Oracle Database Tools User Group, ODTUG, in their Tech Acceleration publication. It's an online publication. By the way, I'm an editor there if you're interested in submitting articles. But I basically laid out the case for using OML, OAC, and then in the last few parts of the article, how to do more in terms of graphing and leveraging spatial and graph tools inside the Oracle database. More on that tomorrow, but you may not be aware of this. Oracle Spatial and Graph is free. It's included inside your Oracle database at no additional licensing cost. So if you've got an ADB instance, you've got Spatial and Graph ready to rock and roll. And yes, that even applies to the always free layer. My friends, you've got an enormous amount of tools at your fingertips. And with that, I'll put my contact information back up. So if you want to reach me, you can do that easily. But otherwise, I'll go take a look if you have any questions. Let me just put my contact information up there. It's somewhere. Yay, almost there. if you want to reach out to me, here's the easiest place to get to me. Let's see what we've got in Q&A.
There we go. It's showing now.
Anybody have any questions? You can, I don't know if we can open mics, but.
Yes, I'm just checking here the Q&A and no questions at the moment. I will wait around another 30 seconds. And
okay.
Basically, also I want to let everybody know that this session, the playback will be available in a couple hours in the conference page. That means that playback will be available for 2 weeks from now. And the people can watch. I recommend you to recommend to your friends, your colleagues or peers to register for free to the event and take a look in the playbacks, because in the playback, you can also add your questions if you miss the live session and interact with Jim, and he can respond to the questions and comments to his session on his session page as on his own convenience.
Okay. Excellent. That sounds like fun.
No questions came through in that case. Thank you so much, Jim, and hopefully you have a wonderful night over there.
Yeah, thanks very much. And I'll see you guys tomorrow night about 10 o'clock, my time. I think 2 o'clock your time. All right,
Fantastic.
stay safe. We'll see you guys later.
Thank you. Bye-bye.
Bye-bye. Good night.
Good night.